Welcome to the Beef Cattle Research Council's webinar on the environmental footprint of beef production. My name is Stacy Domalewski. I'm the Science and Extension Coordinator for the Beef Cattle Research Council, and I'll be your moderator tonight. I'm pleased to introduce our first speaker of the night, Fawn Jackson. Fawn is a Manager of Environment and Sustainability for the Canadian Cattlemen's Association, where she participates in many research and joint initiatives between the beef industry, government, and international groups. Fawn was also instrumental in setting up the CRSB, which she will tell you a bit more about today.
All right, Stacy, is that my go-ahead?
Yep, you're good to go.
Fantastic. Share my webcam. There we go. All right, good evening, everybody. Sorry, just stick with me as I get this all set up. All right, Stacy, you can see my starting slide.
Yep, everything's good.
Okay, fantastic. I'll start. Well, thank you so much to the Beef Cattle Research Council for having me here tonight to talk about the Canadian Roundtable for Sustainable Beef. Certainly, over the last number of years, the whole discussion of sustainability has grown and grown. And I'm very proud to say that the Canadian beef industry has been extremely proactive in engaging this conversation, in leading the conversation globally. And so I'm going to take you through a little bit of the work that has been done by the Canadian Roundtable for Sustainable Beef. I have just a really quick 10 minutes to take you through this work, so at the end we'll be very happy to answer any questions that you might have. So what I'll discuss is who is the Roundtable for Sustainable Beef in Canada, and then quickly give an overview of our 3 pillars of work, which are our National Beef Sustainability Assessment and Strategy, building a verified sustainable beef framework, and then also the sustainability projects. So the Canadian Roundtable for Sustainable Beef, whenever I talk about it, I always start by talking about membership. We are certainly driven by membership. Currently, we have 93 members that span across a multitude of membership categories. So we have food and agriculture business, NGOs, environmental organizations, animal care organizations, processors, beef producers, food and retail service, and a number of observers. It's really important that we have this large multitude of stakeholders to help guide the work. And our mission is really to both communicate and to further sustainability in the Canadian beef industry. When we're talking about sustainability, it's always important to understand what does that all mean. So we talk about the 5 pillars of sustainability. We talk about being a good steward of the natural resources, taking care of people and community, taking care of animal health and welfare, food, and then also efficiency and innovation. And so when people say, well, sustainability can really mean anything, yes, it really can. And the way that I like to think about it is, if I go onto an operation, whether that's a processing facility or a beef operation, are they doing a good job on that operation? And I think that means that they have to include all 5 pillars of sustainability. The 3 core pillars of work of the CRSB are number 1, to track sustainability. Where are we on those 5 pillars across Canada? To build a verification framework, and then also to undertake projects that help advance sustainability in the Canadian beef sector. So first of all, I'm just going to give a brief update of the verification framework. And so we are planning to launch a verified sustainable beef framework in Q4 of 2017. What this means is somebody who wants to source or somebody who wants to supply verified sustainable beef, how do they go about doing it? Well, they would utilize this framework. When talking about the Verified Sustainable Beef Framework, people always ask, well, what's the connection to the McDonald's pilot project? So I just thought I would overview that very quickly. The McDonald's pilot project Their purpose was to begin purchasing a portion of their beef from verified sustainable sources in 2016. They did accomplish this. It was a fantastic undertaking, and they made the commitment right from the very start that they would pass those learnings on to the Canadian Roundtable for Sustainable Beef. So we are absolutely using the framework that McDonald's developed in their pilot project to help us develop our verified sustainable beef framework. It was really excellent that McDonald's made that investment in Canada, and they're continuing to have to support the Canadian Roundtable in this undertaking. So what is the CRSB, Sustainable Beef Verification Framework? It is really to provide a tool to communicate the sustainability of Canadian beef to consumers and enhance the industry's social license and help us on that continual journey of continued improvement as well. We do at the Roundtable, how we operate is through committees. So we have 2 committees that support the verification framework development. We have an indicator committee and a verification committee, and we have tasked them with building this framework with the guiding principles that it is realistic, that it is credible, that it's scalable and cost effective, that it drives real value, and that it also follows international standards for developing these types of frameworks. So we've set them out with quite a large task, but there's a lot of expertise sitting at those 2 committees that are really helping guide that work. So where are we right now? So McDonald's finished their pilot project in June, and we are aiming for Q4 of 2017 to launch a full CRSB verified sustainable framework. So there's a number of different things that we have to complete before we can launch our full framework. Number 1, we need to have indicators for beef operations as well as processing facilities. So essentially that means, what would you measure on those operations to determine if they are sustainable or not. We have to develop an assurance manual, and that includes everything from what are the records that need to be included, who gets to be a verifier or an auditor, what's the audit cycle, those types of things. We also have to develop a chain of custody and what are the claims that can be made, and then determine equivalency between other programs that are existing, as well as developing a marketing and communications plan. So on the left-hand side of your screen, the indicators for beef operations and processing facilities and assurance manual, those have all been through their first draft, and we're just working on their second draft. And on the right-hand side, we have drafts of our equivalency for the indicators. So working really hard to make sure that, that we hit our deadline of 2017. When the reason I would say that the sustainability conversation has been really positive in Canada is due to a number of different factors. First and foremost, we have really excellent producers in Canada who are leading globally in implementing sustainable practices on their farms. So we have a really great story, and this is about telling it and continually working to improve, which all of our producers already do. Secondly, we already have a number of different programs in Canada that can be utilized as part of the verification framework. So whether that's environmental farm plans or rangeland and riparian health assessments or the beef code of practice or on, we have tools that are going to be able to, as producers use them, help with the verification process. We are also working to determine full equivalency with a number of programs. So ProAction is the dairy program. Verified Beef Production Plus is a beef program, and we're working together with those programs to see if we can determine full equivalency. So essentially that would mean if you're on Verified Beef Production Plus, your beef would be fit for a Verified Sustainable Beef program through the Canadian Roundtable for Sustainable Beef. And we've both made commitments, both VBP as well as the CRSB, to work together, because we know that that framework works for many of our producers out there today. In the interim, those that participated in the McDonald's pilot project, McDonald's is maintaining verification with them over the next year, and then we've made a commitment to grandfather those who participated in that program into the CRSB. So thank you so much to all the producers who did participate in that. And we had a lot of lessons learned that came out of that pilot project. So I just want to really quickly visit the sustainability assessment. So in October, we hosted the Global Roundtable for Sustainable Beef in Banff. They have a global conference every 2 years, and we were very pleased to host them. And there we launched the results of our National Beef Sustainability Assessment and Strategy. And just flip through these slides. And the strategy and the assessment really included the assessment part, which included a social, environmental, and economic assessment of how is the Canadian beef industry performing when it comes to sustainability, as well as a strategy for the future. What would we like to focus on to continually advance that? So this is just a slide reiterating that it did cover the environmental, social, and economic assessments. On the environmental front, it's going to be really fantastic to hear from Tim just after myself. We did have a number of stakeholders of the roundtable sit on our advisory committee for this sustainability assessment, and Tim was one of those, and his expertise was certainly appreciated because we had a really large undertaking. So not only did we assess the typical things that get assessed in life cycle assessments, such as how much water do we use, what's the greenhouse gas footprint, those types of assessments, but we also looked at a land use assessment. So what's our connection to biodiversity? What's our connection to soil carbon sequestration? What's our connection to water and risk and filtration and all of those different aspects, including in addition to the social and economic assessments. So it was quite a unique study, and the first of this scale globally. I would just like to, and I can send these links out after, Stacey, if we can share them, the summary reports and the fact sheet. So if anybody ever asks you, well, what is the water footprint of beef production, or just how much carbon is stored there, you can find all of those resources on the CRSB website. So there is a full report and then also fact sheet that summarizes it. We also did a number of different factoids that really help explain, a lot of the science that went in behind there in a very summarized caption. So just an example of that the land where beef production is done in Canada helps preserve approximately 1.5 billion tons of carbon in Canada. And if we value that at $15 a ton, that's worth 82.5 billion. So the Canadian beef industry has many aspects of the climate change discussion that goes into those conversations. These are just a couple of more, so our water number and then also an economic number. So something that really stuck out, I think, for a number of our CRSB membership who perhaps aren't from the farming side was that between 74 and 85% of the cow-calf sector relies on an off-farm income. So when we're talking about sustainability, yes, we talk about environment, yes, we talk about social, but it is absolutely imperative that we're also ensuring that our beef producers are able to make a living off of the land as well. When we're looking at the strategy side, so what do we want to do going forward? This is the link and then also the fact sheet that goes along with that as well. Here are a summary of our overarching goals. So they have to do with 1, building a stronger and more united Canadian beef sustainability community, 2, around climate change, around ecosystem services and biodiversity for number 3, number 4 on riparian health and reducing our water footprint, number 5, reducing post-harvest meat waste. That was a very interesting part of the study. In Canada, in North America, the number is we waste after processing, starting at processing, 19% of beef production is wasted all the way to the consumer. So certainly an area where we can make improvements. On the social side, promoting farm safety, animal care, and then also the best practices regarding antimicrobial use on the economic side, increasing the financial viability of beef production in Canada, as well as the demand. So quite a broad spectrum of goals, and in the strategy document has action items underneath each one of those as well. So Stacey, I'm probably running out of time here. So I'll just quickly fly over our projects. The projects pillar of the Roundtable is really just getting up and running. Right now we do have one project with multi-SAR and cows and fish underway where we're working to build capacity to enhance and monitor biodiversity management on native grasslands and riparian areas. So we do in the Roundtable see a number of different state environmental stakeholders from the World Wildlife Fund, Ducks Unlimited, Nature Conservancy, Nature Canada, multi-SAR, cows and fish, participating because they certainly see the value that beef producers have in helping maintain biodiversity on the landscape and maintaining those very precious native prairie acres. So this is one of our first projects that's underway, and we attained funding from Environment and Climate Change Canada for that project. That is just some of the monitoring pictures. This is just my last slide. Over the last year, the CRSB has really seen some very fantastic success. So we saw great growth in membership. So we're currently at 93 members and observers. We completed the National Beef Sustainability Assessment, and that really included a huge number of individuals across the globe to make that such a fantastic study and very usable for all of the CRSB stakeholders. We hosted the global conference that had participants from over 15 different countries, and completed the McDonald's pilot project. So we verified or McDonald's, and we participated in that, verified 121 cow-calf operations, 20 feedlots, and 2 packers for a total of 8 million pounds of verified sustainable hog carcass weight. So it was a really great year, and we're going to work to continue to make this a positive conversation in Canada to help tell the correct story about beef production and the fantastic performance regarding sustainability of the Canadian beef industry, and also work together to make sure that we continue to maintain that global leadership role. With that, I'll pass it back to you, Stacey, and look forward to questions at the end. You can find us on Twitter or on our CRSB website. You can sign up for our newsletter there.
Great, thank you very much, Fawn. So as Fawn mentioned, she's available for questions at the end. So if you do have any questions, please type them into the chat panel on the side of your control panel, and we'll answer them at the end of the webinar tonight. So with that, I would like to introduce Dr. Tim McAllister. Dr. McAllister is a principal researcher at Agriculture and Agri-Food Canada, where his research focuses on microbiology, nutrition and beef production, food and environmental safety, issues related to livestock E. coli mitigation strategies, prion inactivation, and more recently AMR in bacteria and feedlots. And he's going to talk to you about the environmental side of some of the things he does today.
Okay. Well, thanks a lot, Stacey, and thanks for the opportunity for giving the presentation here this evening. You can hear me okay, and everything sounds all right?
Yeah, it sounds good.
Good. Okay, so what I was going to talk to tonight is regard to the environmental footprint of beef production. And this is really an activity that's going on globally now, not only related to beef production, but really all food production in the world is being looked at from the environmental footprint that it produces. My talk tonight will be both from a Canadian perspective, but as well as from a global perspective, and what's going on in some other countries with regard to defining the environmental footprint of beef production. Just the slides to change. Seems to be stuck. There we go. So what's the challenge that we're facing, like from the perspective of the beef industry? Well, a lot of it has to do with what we've heard in the popular press a lot with regard to cattle and their contribution to methane production. I always get a kick out of this particular diagram or picture they've got here because it obviously shows that it was put together by somebody who didn't understand the physiology of cattle, because the majority of the methane actually comes out of the front end of the cow, not out of the back end. So, but cattle do produce a substantial amount of methane as part of the anaerobic digestion of feeds within the rumen, and it's really that ability to digest feeds within the rumen, especially feeds high in plant cell wall content, that gives makes ruminants unique in terms of their ability to convert low quality forages into high quality protein in the form of meat and milk. But we've also heard about those emissions being associated with groups starting out with programs like Meatless Monday, to not eat meat on a Monday, to stop global warming, eat less meat. We see documentaries coming out that are talking about the role that intensification has in meat production and the environmental consequences of that. One of the later ones that just came out was the Cowspiracy documentary that was also released on Netflix. A lot of these really fail to give the complete picture of beef production. They often use the worst case scenarios. For example, this particular documentary uses figures out of a paper that was produced by an organization called World Watch in the United States. And there was a number of international scientists, of which I was one of them, that wrote basically a rebuttal to the numbers that were used in that particular paper. And these were people from all over the world that are working in this area that basically refuted many of the figures that were being used by that group. And basically those exaggerated figures are the basis of this. They're what ended up in this documentary. So lots of times they're looking for the worst case scenario, but we continue to hear and see this kind of information being released in the popular press with regard to the environmental impact of the beef industry. But often we have to realize that that information is really coming from groups with special interests. It's often exaggerated outcomes, as I mentioned. They're often also quite narrow in scope, in that they really don't look at the beef industry as a whole and the various positive and negative aspects of that industry. They tend to focus primarily on the negative. Now, that being said, some of the data that is being presented is not without merit. Like, it's undeniable that ruminants produce a significant amount of methane as a result of that fermentation that I talked about. But I think it's important that we also understand the dynamics and the interrelationships within the industry, so that we can develop our own positions in that with regard to where beef cattle fit in overall food production and their implications for the environment as well. And really the objective is to empower the public, so if whatever they decide in their diet decisions, all of us are entitled to make those decisions as we desire, that they're making those decisions from an informed perspective, so that if they advocate reducing the number of feedlots, as for example, in beef cattle production, that they have an understanding of what the ramifications of that will be for and other factors such as increased greenhouse gas emissions. So we all know how important the beef industry is for Canada. It represents about 68,000 producers across the country, generates about $33 billion annually to the Canadian economy. We're quite significant in being the 5th largest beef exporter globally. In 2014, we exported about 1.4 million tons of beef. As the world population continues to grow, so does the global demand for beef. And in my travels at various places in the world, I see this increase in demand in countries. I was just in Africa, and I saw an increased demand there, in China as well. Generally, as countries become more wealthy, their demand for, and individuals have a higher income, they end up having a higher demand for meat as well. And quite often that's related to a higher demand for beef. So what are the implications of that footprint? I want to talk a little bit like within the beef industry as well. We have to consider it for both beef industry industry and technology developers. A lot of the technologies that we're going to see emerge and that are going to be used in the beef industry are related to reducing the impact of that footprint. We have to be aware of it as well for beef consumers, so that some of the stuff that Fawn was just talking about with regard to sustainability metrics and ensuring that the Canadian beef is being produced with a consideration for those. And then also, even though vegetarians and vegans may not select to purchase the products of the beef industry, they still have a voice within the public. So gaining their confidence as well should be something that we should be thinking about in terms of the sustainability and of beef production and the environmental footprint that is associated with it. So what are the components of the footprint that I want to talk about? Well, one is related to greenhouse gases and climate change. So that's really related primarily to the methane emissions that I talked about earlier. Another is related to carbon sequestration and land use change. Finally, the water footprint, impacts on biodiversity, and then ecosystem services as well. So Stacy, can you do the little survey that we were going to do here now, or how do we do that?
Sure.
Okay.
All right. So we just have a couple questions that you guys can participate along at home with us. So your answers to these questions are anonymous to everybody else who's watching. So the first question we have is, how concerned are you about social license on your operation? So not very concerned, somewhat concerned, concerned, or very concerned. So you can type in or click which one most applies to you. And we'll just give a couple more seconds here for people to finish getting their answers in. All right. So it looks like about 3% of people say they're not concerned, 21% say somewhat concerned, 36% say they are concerned, and 39% say very concerned. So our next question here. So for this one, you can choose all that apply to you. So which of the following sustainability priorities are a concern on your operation? So Fawn talked about these earlier. We talked about natural resources, people in the community, animal health and welfare, food safety and quality, and efficiency and innovation. So go ahead and click all that apply to you. And I'll give you a little longer with this one because there's a little more to do. And once again, just a reminder that your answers here are anonymous to everybody else who's watching as well. All right, so results for this one. It looks like natural resources at about 76%, people in the community at 55%, 82% for animal health and welfare, 64% food safety and quality, and 76% say efficiency and innovation. So a lot of them clicked on most of them anyways.
Okay, so I think that in itself illustrates that there's a growing awareness of many of those factors that really do contribute to the social license to operate, and the growing awareness of the level of communication that we have, you know, through the internet, and how rapidly information can be passed. Some of that information is valid information, some of it's misinformation, but gaining consumer confidence, I think, really shows that. And as Fawn mentioned, I think the Canadian beef industry is actually leaders in that perspective of that level of awareness globally, and I think that's a big advantage that the industry has. So if we move on to looking at some of those specific parameters in terms of footprint, part of what I want to do is just give you an idea of the larger perspective here, so that, you know, when people start to criticize the beef industry and its role in a footprint perspective, from the larger perspective of total greenhouse gas emissions, that you have an appreciation for where it fits into the overall bigger picture. So in this particular figure I have here, here's the atmospheric emissions of carbon dioxide levels in 1870, which is around 288 parts per million. In 2014, we're up over 400 parts per million now, but in 2014 it was about 397 parts per million. And this just illustrates the factors that contributed to that increase over time. And you can see that the coal industry had a major contribution to that, as well as oil and gas, and even cement production. A lot of people don't realize it, but cement involves a substantial release of carbon dioxide. So every time we build a building or a cement highway or those kinds of things, that also contributes to the greenhouse gas emissions in the form of carbon emissions. And then we have land use, which is really related a lot to the conversion of grasslands or forests to agricultural land for cropping, which was also associated with those emissions. And you can see that the land sink, then the carbon that's taken up by the land is actually greater than the amount of emissions that were associated with land use. And then we also have the ocean, which is a considerable sink of carbon as well. But you can see that that sink goes, really doesn't come very close at all to offsetting the total amount of emissions that have taken place. And when you look at those amount of emissions, the overwhelming majority of them have come from the use of fossil fuels. So the reality is, although we talk, we hear a lot of talk about agriculture and its contribution to climate change and greenhouse gas emissions, if we hadn't used fossil fuels, we wouldn't be talking about climate change. Now, that being said, we also have to realize that what we've got through the use of fossil fuels have gone a long ways to improving the quality of life for humanity as well. And so there's really a balance there, and it sort of comes back to there being, no free lunch, that if we want to have the kinds of controls and transportation, etc., that we can have as a result of fossil fuel use, then we're going to have increased emissions. But certainly the problem that we have today is not due to agriculture, it's due to the use of those fossil fuels. Now, if we look at agriculture specifically in terms of total emissions, it accounts for about 24% of total anthropomorphic greenhouse gas emissions. And so that comes from all of these various practices, which include the burning of crop residues. I was just in China not that long ago, and the amount of burning of rice straw that goes on there, even though it's against the law, is unbelievable. And in terms of its impact on air quality, you just have to be there to experience how bad it actually is. But some of these practices are very difficult to change, even when it's recognized that they have a negative effect on the climate through greenhouse gas emission production. The actual, out of all of the various sectors that are monitored, agriculture is the only one that really had a net emissions reduction in the last decade. And a lot of that is due to a reduction in land use change and deforestation. So there's been huge changes in the Amazon in terms of, for example, of reversing the deforestation and putting a stop to that practice. And in many northern areas, we're actually seeing increased forestation. So in a lot of northern climates where the boreal forest and that is, if some of those areas are not continuously cleared, they'll grow back to forests in a relatively short period of time, 100 to 200 years kind of thing. So it doesn't take that long for the forests to come back. And those are the factors that have really resulted in a reduction in emissions. In the other sectors, we've still seen an increase in emissions. A lot of that is related to the fact that we require more food to feed the growing human population that we're projecting to reach 9.5 billion or so by 2050. Now, when we express those emissions on an intensity basis, which is per unit of food produced, we can see that in all sectors, over time, we're having a reduction in the amount of emissions per kilogram of product produced. So that just reflects advancing technologies, and that we're getting more and more efficient from a global perspective in terms of how efficiently we can produce food. And so the amount of emissions per unit of product is declining as a result of that. Now, that you have to be careful to make sure that you have the correct metrics. So that's a reduction in emissions per unit of product produced, it doesn't mean, though, that we don't have an increase in total emissions. There still can be increased emissions simply because we're producing more food, but the amount of emissions per unit of food is decreasing, and that's because of the technological advancements in terms of animal breeding, nutrition, additives, a whole wealth of different technologies that have contributed to that overall improvement. And Canada has done well in that sector as well. This is part of some work that we did of a comparison of the carbon footprint of Canadian beef production over a 30-year period. And basically over that 30-year period, we've seen a 15% improvement in terms of reductions in the amount of emissions per kilogram of beef produced. And a lot of that is also related to some of those same factors. So additives have played a role in that. Increased carcass weight at slaughter, reduced time to slaughter, genetics of the animals, improved nutritional practices. All of those have contributed to the efficiencies. You really can not really identify any one single factor that contributes to those efficiencies. It's a multitude of factors which combined then lead to that overall improvement. So when we look at the footprint of beef production, it really has one of the more complex footprints, and it really represents the complexity of the industry itself, in that we, as the industry as a whole, manages vast tracts of land in terms of the cow-calf operations, and many people in the general public don't realize that in the extensive part of our production system, which really is the cow-calf sector, which is almost exclusively dependent on the utilization of forages within that sector itself. Then we have where cattle can then enter into the more intensive production practices, like in the feedlots. We have a variety of different finishing programs, whether it be straight into finishing type diets where cattle can be slaughtered at as young as 16 months of age, where we're using higher forage-based diets followed by higher grain diets where cattle are slaughtered in approximately 18 months of age, or whether we have a system where we're putting cattle back out into the pasture for a period of time after winter and then finishing where we're looking at about 20 months of age. So we have all of these various types of scenarios in which the cattle can be ran through, and as a result the complexity of the footprint becomes quite great as well, because we're using different feeds, different environments, different housing practices, all which alter the nature of the footprint that we estimate. So when we made that calculation of the 15% improvement, we considered all of these in the Canadian beef industry as a whole and that complexity in those estimates. Now, when we look at emissions, why we need to think about each of the sectors is because each of those sectors within the beef production cycle have their advantages and disadvantages from the perspective of the footprint that they produce. So if we look at more extensive systems, so let's say if we're looking at grass-finished beef, because the amount of emissions associated per kilogram of beef produced are greater with forage than they are with grain-based diets, then the amount of emissions in an extensive-based system is higher than it is in an intensive system where we're using higher grain diets, higher energy, where the amount of time and the amount of emissions per kilogram of beef is reduced. Now, if you compare some of those emission levels, obviously when you're looking at something like meat substitutes or pulses as a protein source, then the amount of emissions associated with them are substantially lower. But you also have to think then when you go to an extensive-based system in the beef cattle production, we're talking about the preservations of vast tracts of grasslands, whereas if we're talking about pulses and beans, if we want to produce those, we're basically cultivating those lands up and using them as croplands in order to produce that protein source. And that's been a major driving force in countries like Brazil as well, where often what was happening, and a lot of people didn't realize it, is that the cattle were originally out grazing natural grasslands. Those grasslands then were converted to soybean production because they were the quality of the soil in that was amenable to high levels of soybean production. So the soybean was in fact displacing the cattle off the grasslands, which was then forcing them into deforestation and development of lands from the directly from the forests themselves. So a lot of these things are more complex than one sees unless you actually go there and see these conversions taking place. So why is the footprint of beef typically higher than other livestock species? And it really evolves all around the concept of feed efficiency. And so the amount of feed required to produce per kilogram of meat, beef has a lower feed efficiency. That's in part due to the type of feed that they consume. Poultry is the most efficient, followed by pork. So in case of ruminants, where if we're talking about a grazing-based system, the feed efficiency is lower because it takes more feed, more energy to basically break that material down and provide the energy to the animal. And the amount of energy they derive from it is not as great as if they were being fed a grain-based diet. So with our intensive-based systems, our feed efficiencies are improved, and so the amount of feed per kilogram of beef may be as low as 4 to 1 or so. Whereas when we're talking about forage-based diets, we may be up to 8 to 1 or even 12 to 1 if we're feeding really low-quality forage. Whereas poultry, because of the nature of the diets they're typically fed, the amount of variation is far less and the quality of the diets are usually much higher, so the overall efficiency is greater. Now, that being said, with poultry, we've done a lot in terms of selecting our poultry industry for growth. If we look at the broilers and that, in very controlled climatic conditions, inside barns where temperatures and humidities, lighting, etc. are carefully controlled. So you create an environment within the poultry barn such that it's pretty much the same in Canada as it is in the United States as it is in China. Whereas with their beef production system, the beef is outdoors, not typically indoors, and as a result, they need to have the diversity within their genetics to adapt to a wide range of environments. We can't control all the environments that beef are exposed to like we typically do with poultry. And so with those broiler types of breeds, they're so adapted to those barns that if we turn them into a free-ranging system, they wouldn't survive because they need such high levels of nutrition and controlled environments. They can't deal with temperature extremes, etc., that they can't genetically do well out in a broader environment. So that's one of the reasons why with the beef industry, we have greater genetic diversity so that they can adapt to the various environments that they are within, and that difference even exists in a province like Alberta between the parkland region where we're talking up north or where we're down in the native grassland areas like down by 1-4 and in the southern part of the province. Now, along with that, when we look at the type of diet that's fed, if we look at the amount of grain consumption, then beef as a whole typically have the lowest amount of grain consumption relative to pork and poultry. And the advantages of that is one of the criticisms of using grain for livestock production is that that could be food that could be used for human consumption. Now that really depends a lot upon where you are in the world. If you're in Africa, that's often a fact in terms of a lot of those grains are used directly for consumption by people. If you're in a place like we are here in North America, a lot of that grain that is going into whether it be any of these livestock production sectors, has really failed to meet the grade for human consumption according to our standards. So for example, barley, a lot of the barley that's targeted towards malt for brewing that doesn't make that grade ends up as feed. And likewise with wheat that does not make it as grade for use in pasta, bread, or flour, etc., ends up being downgraded and designated as feed wheat, and is then utilized by these industries. So it really depends on how you look at it. Now that wheat still could be consumed by people as well if there was a demand for it and if it could be transported or exported to meet that demand. So along with looking at what we can do, I talked about some of the efficiencies and the technologies that we can use to reduce greenhouse gas emissions. There are groups that are advocating that, as I mentioned, that we can just eat less meat. And so this graph just sort of targets or demonstrates some of the models that have been ran looking at various scenarios and what their impact would be on emissions that are associated with livestock production. So this is the total emissions that are associated with all anthropomorphic activity of 2010. So this is all sectors combined. So that's what this bar here illustrates. This represents the level of which we need to achieve to hold the temperature rise to 2 degrees Celsius. So the meeting that they just recently had in Paris is trying to hold the temperature increase to no more than 2 degrees Celsius by that time. This shows the various amounts that would occur of emissions associated with livestock production. So if we have an increase in meat intake, then this will be the type of emissions that we'll have. If we increase agricultural yields, so more crop production per unit of land that is utilized, then the amount of emissions associated with that would reduce by this much. If we reduce waste associated with food by 50%, then we have a further reduction in emissions. If we use what they call a low meat diet, so we reduce our meat intake on a global basis, you have a further reduction. And then if you combine all those things together, you end up with a reduction that's this large. And you can see there's a number of different scenarios where they've gone through where they're all the way from eating no meat or fish and the reductions associated with that modeling exercise, as well as going down to a 15% reduction, no meat, eggs, or dairy, so taking basically pretty well all livestock products out of the diet. These are the kinds of reductions that you get. So you can see that all of those do result in some declines, but none of them come close to achieving the overall reduction that we require. So that's one thing to think about. And I think the other thing to think about is also related to human behavior. So if we look at the opportunity for reducing intake, there's no doubt that there's individuals within society that have chosen to be vegetarians or vegans. That population, whether it'll increase or decrease, it depends. A lot of people are often only vegetarians for a certain portion of their life, not for their entire life. So that's one factor that might affect that. The other is, if we look at the global trend in terms of wealth, global wealth, and the selection of people for choosing to eat more meat, that there's a good chance that meat consumption is actually going to increase as opposed to decrease on a global basis. And so if that's going to be the scenario, then we need to be looking at technologies or methods of where that meat can be produced as efficiently as possible to reduce the amount of emissions per kilogram of meat that's produced to the most efficient level that we can achieve. So this is just basically then an estimate of where we're going to get the improvements in order to meet the food requirements that are predicted to 2050. And if you look at this in terms of increased land expansion or agricultural area expansion, there's actually very little opportunity to achieve increases in the amount of agricultural land that's put in production. If anything, depending upon what happens with climate change, we could actually have a decline in the amount of available agricultural area due to desertification and other deterioration, water shortages in various areas that could lead to a reduction in the amount of agricultural land that's available for production. By far the greatest improvement is going to occur through intensification. And then there will be some changes as well, this small part you see here in relation to demand management. So that would represent a reduction in the amount of meat that's consumed. So intensification involves producing more food with less resources. And a lot of that really does fit into the intensification of livestock production as a means of achieving those goals. And so if we're going to do that with the lowest amount of emissions, this intensification is the way that that will be achieved. Despite the fact that many people are advocating that we need to go back to less intensive, extensive farming systems. And the truth is that if we do that, we won't be able to meet the food demand of the human population. So these are just some scenarios I mentioned trying to hold the RCP6, which is holding it to a 2 to 3 degrees increase in temperature. That's the goal we're trying to achieve. There's some bad case scenarios where we could have up to a 5-degree increase in temperature by 2100 as well. And some good case scenarios where we could be less than a 2 degrees increase in temperature. So these are a number of various scenarios. Probably this mid type of scenario here is the one that's most likely to occur given the current rate of emissions that we're currently experiencing and what appears to be, at this point anyway, the rate of change in behavior that's taking place to reduce those emissions overall as well. Now, obviously there's unknowns that can impact that. The recent election in the United States, Obama had bought on and was really part of the Paris Accord that was signed. Trump is indicating that he's not interested in that and he may back out of that completely. So those kinds of changes that we can see globally can have an implication for the ability to meet these targets depending upon what countries do in terms of trying to control their emissions. So this next graph just sort of illustrates the energy consumption that's taking place right now. And it gets back to that first graph that I showed, just showing the overwhelming amount of emissions that are associated with coal, oil, and gas. And although there has definitely been a trend to reduce the rate of increase of those, they are still increasing in terms of the use. So even at that point where we widely recognize the contribution of the utilization of these fossil fuels to greenhouse gas emissions, on a yearly basis, we're still having an increase in their utilization. Nuclear has declined lately. A lot of that was with the Fukushima, the disaster that they had there associated with the tsunami really turned people off of using nuclear power. Germany is shutting down a lot of its plants. Hydro has increased some. We've seen a dramatic increase in the amount of renewables, so that's things like wind, solar, biomass utilization, biodigestion, etc. So you can see there's been a big increase in that, but when you look at that increase relative to total use, it's a drop in the lake in terms of the total use that's going on. So as long as this trend continues, then we're going to continue to see that contribution to the climate change through increased CO2 emissions. And I was in China not too long ago where I saw, you know, the amount of coal they use, where they would be just basically B trains of coal being hauled into their plants, their electrical generation plants that they have, lineups of truck converting coal into carbon dioxide as they produce the electricity from that system. So even though China says that they're, and I did see solar there, and they are making steps to try to move away from coal, there's still a lot of coal used for energy generation. So this next graph just sort of illustrates the amount of carbon that's associated with soil. So we're looking at about 3,000 gigatons of CO2 equivalents that are in the atmosphere. Today, the production from fossil fuels, the largest one that I mentioned in terms of contributing to that, atmospheric growth as well. Land use change, although it's declined, is still contributing to emissions. But the land is a tremendous sink of carbon as well as the ocean. And the actual total amount of carbon in the land is greater than the amount that's in the atmosphere. So that still represents a substantial store of carbon within the agricultural lands, and depending upon how we manage those lands can determine whether that carbon stays there or is emitted and ends up being in the atmosphere. Now there's a major push then to try to increase the carbon sequestration in soils. And there's a number of different approaches to that, but they call it the 4% target. This is being driven by France in terms of increasing the amount of carbon by 12.9 into that land sink, combining that with the sink that's already there at about 10.6, along with the ocean, and basically you turn it into a carbon neutral system if we stop the atmospheric growth and we stop land use change, so that you could end up with a balanced system. Now, that's possible, but it's also extremely, I think, optimistic to try to achieve this level of sink within existing land, given the agricultural practices, urbanization, etc., that's going on as a result of activities, anthropomorphic activities. So we've all probably are fairly familiar with no tillage and how that can contribute to carbon sequestration within soils. A lot of the carbon that's stored, we can really look at it from the perspective, at least the organic carbon from a microbial perspective. So that carbon is present within the soils. Its availability to breakdown and utilization by the microbes depends on a lot of factors. But tillage is one thing that can definitely make that carbon more available. And when that carbon is broken up and made more available as a result of tillage, then the microbes can utilize that carbon, carry out aerobic respiration, and expire that carbon dioxide into the atmosphere as a result of that activity. Now, we've done some modeling here at the center where we've looked at the implications of cultivating up grassland relative to taking cultivated land and planting it back to permanent pasture. And when we modeled a beef cattle production system, and we looked at the model where we modeled as if we had just planted all of that cropland back to forage in order to provide the forage for that cattle herd, the amount of carbon we sequestered as a result of that process turned the entire beef cattle operation into a net carbon sink. And so that just gives you an idea of the amount of carbon that can be stored within that soil if we convert it from cropland back to permanent grasslands, or the amount of carbon that's in those grasslands that have been undisturbed. And so I think that that's really something that on the global perspective in terms of the contribution of agriculture to climate change was lost, in that there was really no credit given for that carbon that's stored in those grasslands. And the reason for that is because it was really, they were focusing on a change in activity. So if that carbon was already in the grasslands and it wasn't disturbed, and it was there at the time they set the baseline date, then no credit was given for that carbon being there. And I think that that's something that needs to change in how we look at greenhouse gas emissions and carbon and the role that land has in the storage of that carbon. There has to be some recognition of practices that help preserve that carbon in its present form. Now, the carbon residency time in soils differs a lot depending upon where you're talking about that carbon line within the soil profile. So the soil, the carbon that's in the upper few centimeters, say 0 to 30 centimeters, represents relatively short-term carbon. So that's very mobile carbon that has a rapid turnover. So it ends up being emitted as carbon dioxide and also being utilized again by the plant in terms of photosynthesis as carbon again to rebuild more plant material. So I think it's important to recognize the difference between carbon sequestration and carbon capture. So if we're talking about the growth of the plants here, we're capturing carbon dioxide every time we grow a crop out of the atmosphere. But that carbon may be very short term and not sequestered for a long period of time because it's typically mainly in this upper 0 to 30 centimeters. As we go deeper into the root zone and then that carbon can last longer, maybe upwards of 6 months. When we get even deeper into the where a large portion of the carbon is, it may last for 20 years, and then in the very deep soil we end up with carbon that may persist for up to 1,000 years. So all of those vary dramatically, and our practices can impact the amount of carbon that's sequestered across that continuum. And one factor that can affect that is obviously the root growth, and this is just illustrates some various grasses and etc., sedges and that grow out on native grassland, and just shows the various depths of roots in terms of their penetration. And you can see that depending upon the type of grass or species you're talking about, the amount of root development varies dramatically between different species. Now, typically native plants tend to be quite deep-rooted in nature, whereas if we're talking about something like Kentucky bluegrass, you can see here we have very little root development and carbon being, basically entering deep within the soil profile. And in fact, that can have quite an impact on the amount of carbon that's in the soil. I was at a meeting not too long ago where there was a presentation by a fellow out of Wisconsin who had looked at cropland that had been reestablished to something like Kentucky bluegrass and had been measured. He measured the amount of carbon that was sequestered, emitted from that system. And in fact, even though they had converted that cropland into grassland, because the type of grass that was there was of such a shallow rooted nature relative to the natural grasses that were probably there previously, which were much deep rooted, they were actually still measuring losses of carbon in these deeper zones because this particular species of grass was not really contributing to carbon within those deeper root zones. So that can all have an impact on the amount of carbon that ends up in the soil profile. There are things that we can do too in terms of management of the grassland that can affect the amount of carbon that's deposited. So this just shows grass that was under low, medium, or high grazing intensity. And obviously, if you have very high grazing intensity, then the amount of energetic demand on the plant to produce up material that's exceeds above the ground relative to below the ground, the amount of energy that's directed towards growing up ground because it has to carry out photosynthesis is greater, so the amount of energy that's directed towards root development is less. And so here where we have low grazing intensity, you have greater root development relative to where you have high grazing intensity. Now how much that makes a difference, that might, you know, in this case they carried out high intensity grazing for a number of years. A single year may not be really enough to have a huge impact on the plant, whereas long-term management like that could have a long-term impact in terms of the amount of carbon that's available in the soil profile. The other thing to keep in mind from livestock is the value of manure, and it was quite interesting. I was just in Africa, and typically here in North America we see manure as a waste product. In Africa they very much see it as another valuable product that arises from the overall livestock production system, and they were, in some cases, they were making almost as much money off of selling their manure as a fertilizer source as they were making off of selling their milk as a food source. So one of the big advantages, this is some data coming out of Rothamsted, which is the longest continuous monitoring of a farming system in the world from an experimental perspective. And what they've done is they've, since 1850, continuously provide farmyard manure annually, and you can see what that's done to the amount of carbon that's associated with that soil. It's continuously gone up. It's plateauing somewhat compared to what the original rate of increase was, but it's still increasing. In 1852, when they stopped manuring a particular plot, you can see how they immediately had a decline in the amount of carbon that's associated with that. And then in the area where they never did apply manure, there was no increase in carbon associated with that practice. So I think that's something that we need to use as a good news story, because when we're talking about chemical fertilizers contribute no organic carbon to the soil whatsoever. And it's really, manure is unique in terms of its ability to increase the carbon of soils through the organic matter that it contains. And the persistence of that organic matter also depends upon the nature of the manure that's applied. The less mobile that carbon is, then the more likely that carbon is to accumulate within the soil profile. Now, when we disturb that land area, as I said, carbon can be sequestered over time, but the models that we have presently suggest that that sequestration doesn't go on forever, that it reaches a plateau after a certain period of time. Now, the duration of that time is a matter of debate. It could be anywhere from 20 to 100 years. It probably depends a lot on the type of soil conditions you're talking about, environmental conditions, etc. All of those things can affect the duration and how rapidly that sequestration takes place. But basically, eventually it moves towards an equilibrium, and the increase, if any, is very small after that point. But I still don't think that that should be looked upon, you know, the value of the carbon that is sequestered there, even though it's relatively constant over time after that plateau is reached, still represents a major value in terms of the carbon that's been removed from the atmosphere that's associated with that sequestration. And of course, we can do things to reduce that and cause that curve to start to decline and go back the other way again. And those are practices that we want to try to avoid. So there are many places that are looking at this whole carbon sequestration and even the amount of carbon that's already been sequestered in grasslands and the role that it can play in the overall beef production system, because we're not the only country that manages vast tracts of land within our beef production system. And Brazil is a good example as well. They have an extensive grassland area, as illustrated here, and they really have a big program now to what they call producing carbon neutral beef. And the overall objective is to increase the sequestration of carbon in this grassland area to the extent, very much like I described with the modeling that we did with a single farm here in Canada, where in this case Brazil's objective is to sequester sufficient carbon in these grasslands to turn the entire Brazilian beef production system into a carbon neutral beef production system. That's their objective. They propose to do that. A lot of those grasslands are in a very degraded state. They've been overgrazed for a long period of time. So they're proposing to do that by improving their grazing practices. They're also proposing to do it by increasing the use of legumes in those pastures as a method of improving nitrogen availability in grassland production in that manner as well. And they're also looking at using more fertilizer as a means of improving grass growth as well. Now, increased use of chemical fertilizer in itself has associated emissions. But they did some work as well modeling various scenarios with and without deforestation. And so this represents increased demands here. You can see of 10, 20, 30% increase in demand for livestock production, beef production. This represents a decline in requests or demand for beef as a whole. And this represents the changes in emissions with no deforestation, so in this case without expanding the amount of available grassland, and in this case with deforestation. So right away you can see the dramatic impact that increased demand for beef would have if deforestation was allowed to take place. So currently, as I mentioned, Brazil has a lot of programs in place to stop deforestation. It's illegal to cut down the rainforest now, and that's not to say it doesn't happen at all. But there are major fines and there are people monitoring for that to be happening to make sure that it doesn't start to reverse. And that, as I mentioned earlier, is why one of the reasons why we're seeing a net reduction in emissions from agricultural forestry is because of that deforestation being stopped. But obviously, if deforestation was allowed to take place again, increasing demand leads to increased deforestation and a result increased change in emissions. If deforestation doesn't take place, then the amount of sequestration that can take place as a result of pasture with that increase in demand is substantial. And that really represents an increase in intensification of the production system. So if you produce more beef per unit of acre, then that system represents, or per hectare, that represents an increase in the intensification. Whereas if they go to a reduction in demand, and intensification is not part of that package because the demand for beef has gone down, and you go to more extensive systems which are less intensively managed, then the amount of emissions per unit of beef produced can actually go up, even though the demand for beef has gone down. And so those are the kinds of things, and I think a lot of times the consumers don't realize what an impact the basic overall production practice can have on the amount of emissions that take place. So that being said, even though I indicate how important the carbon is within the grasslands that are managed by beef producers, I think it's unrealistic to think that we're going to reverse the effects of climate change simply by sequestering more carbon in grasslands. We have to remember that the petroleum and really the sources that are leading to the primary cause of climate change is associated with the utilization of those fossil fuels, which really took anywhere from 50 to 300 million years to develop in those deposits that we're currently tapping into and utilizing. So really, if we're going to deal with the true problem, the only real solution is to stop using so much fossil fuels and develop alternative energy sources that do not result in the emissions of those greenhouse gases into the atmosphere. There's no doubt that grassland management, increased conversion of cropland to grassland could play a role in carbon sequestration, but it's not going to solve the problem on its own. So I just want to move on then a little bit away from the greenhouse gas and climate change topic towards the water topic. There's water footprinting going on. The meeting I was in Africa was actually on that topic, was dealing with defining the water footprint of livestock production. And we've all seen or heard of these massive figures that are associated with beef cattle production. A lot of those are related to the water and some of those grassland areas that I talked about. Some of those calculations have literally been done on the basis of there being a cow within a quarter section of land. A rainstorm goes over and all the water within that rainstorm is allocated to that cow because she happened to be there when the storm went over. So that's one of the things that one of the roles I have on that committee is trying to get that kind of thinking changed so that the amount of water associated with livestock production is very much related to the amount of feed that's consumed. And that'll bring these numbers down more into the kinds of ranges that Fawn was reporting about, around 600 to 700 liters as opposed to 15,000. Much more realistic in terms of the estimates. The other thing I think is important is that a lot of times it's described as the water is being used, and water is really not used. It's really part of a cycle. So we have large amount of water as a result of transpiration from plants and from surface evaporation, regardless of whether livestock are in the picture or not. We have surface runoff, of course, into lakes and streams, which eventually ends up finding its way into the ocean. Some of that water is used for irrigation. We still have transpiration and evaporation as a result of that. The amount of water consumed, there's a certain amount of water that's consumed with the feed by cattle, and there's also water that's consumed as a result of drinking. But that really represents a very small proportion of the total amount of water that's associated with beef cattle production. And this really just illustrates that about 95% of the beef's water footprint really comes from the overall feed production, and only 5% is associated with the beef itself in terms of consumption or processing, retail, or consumer use. So that there are things that we can do in terms of improving the utilization of water and the efficiency of water use. Some of those are going on continuously in terms of improvements in irrigation technology. A lot of the open canals here in southern Alberta are being converted to pipeline systems, which really reduces the evaporative losses that take place from the canals. We can use more efficient crops that require less water per unit of yield produced. We can increase production practices to conserve soil water, such as leaving more aftermath on the field after harvest. There's also things we can do in terms of improving production efficiency. So if we produce more beef per kilogram of food consumed, then we also lower the amount of water that's associated with that footprint of that feed that we're providing to the cattle. And of course, pasture irrigation can have a positive effects there. There's also things that can be done in the processing end of things in terms of recycling closed-loop water systems, and that to reduce the amount of water that's required in the beef processing sector, retail sector, and of course in the consumer. Fawn mentioned that as well in terms of reducing food wastage is another big area that we can do to lower our overall water footprint. But it's important to remember that the majority of that water footprint comes from feed, and it's likely that that land, you know, if we didn't have cattle that was utilizing that feed, it's unlikely that that land would remain barren. So there would still be crops produced on that land, and those crops would also have an associated water footprint, regardless of whether they were fed to beef cattle or not. So we have to keep that in mind, that just taking the beef out of the system does not eliminate the need for water for crop production. Now this is just some figures of the amount of water consumed by various classes of cattle per day. That range represents one of the major factors that can affect the amount of water consumed is the temperature. So higher ambient temperatures lead to increased water intake. Obviously in Canada, we don't have the levels of heat stress that they have in some more southern climates. And that partially also leads to the fact that our water scarcity issues are not as great as they are in many regions of the world as well, because in reality Canada has an abundance of water. It doesn't mean that we shouldn't be cognizant about using that water efficiently. But it was quite interesting when I was at that meeting in Africa just recently. I was talking with a colleague from Tunisia. He was telling me that in his dairy cattle production systems, 20 to 30% of the cost of the production system is associated with the cost of water that he has to pay in order for those systems to utilize that water in dairy cattle production. So that just gives you an idea of the variability there is in water scarcity, water demand, and water value, depending upon how scarce it is in various regions of the world. So this just shows the amount of water per pound of carcass weight. So drinking water consumed, more water is consumed in the cow-calf sector, mainly because that period of time is longer than when we're talking about stocker or feedlot cattle. But when you look at the non-precipitation water use, the highest is associated with the feedlot, and that's really explained by the basis of the irrigation that's used to produce the feed crops that are then fed in the feedlots, whereas the cow-calf is primarily out in the rangeland conditions where the water is not used directly. Irrigation is not used that often, or neither is groundwater pumped as a water source for production of those rangeland crops or rangeland forages. So that's in relation to the water itself. When we talk about those grassland areas, I think we also have to be cognizant that many of those grasslands also act as filtration in terms of water quality. A lot of the groundwater that we end up drawing from our wells do fall into those grassland areas as subsequently replenishing groundwater reserves. So even though those lands, that water's not maybe directly used by the animals that are out in that pasture, it could be used in some of the wells in that at a distance from the point of where that rainfall takes place. Along with those grasslands, they contribute dramatically to biodiversity. If you look at some of the prairie type, tall grass prairie, only about 1 to 4% of that's remaining. A lot of that has been broken up and cultivated into cropland, and so a lot of the grasslands that are still retained are under grazing for beef cattle production, and the same with the short grass prairie, and with Alberta grasslands about 43%. And then we often forget though, but a lot of our wetlands as well are associated with those grasslands, which are obviously very important for a lot of the migratory birds and that as well. In addition, a lot of Canada's species at risk, such as the sage grouse, a number of the prairie songbirds, mammals like the black-footed ferret, swift fox, are all inhabitants of those grassland areas, and that are preserved for a large part because of the grazing that goes on in those environments. So although we can look at saying from the perspective of greenhouse gas emissions, emissions may be greater in cattle that are produced under grassland conditions, we have to balance that with, if we look at the biodiversity of a grassland system relative to a feedlot, obviously the amount of contribution to the biodiversity is greater in that grassland beef cattle production system than it is associated with a feedlot. And that's why I'm making the point is that it's important to have a appreciation for the various contributions that the beef cattle cycle makes to the various parts of the footprint that we define. Beef production also has implications for ecosystem services across those continuums of those production systems. Obviously, pasture management, how that is managed, whether it's managed in a manner that avoids invasive species, the protection of those natural areas. If we're talking about confined systems, how that manure is stored and handled, how those nutrients are reintroduced to the land, if we're using antimicrobials or pesticides for weed control or insect control, how those are being utilized. Are they being used in a prudent manner? Fertilizer application, tillage, irrigation, etc., trying to maximize efficiencies there, matching the amount of fertilizer that's provided to the needs of the crop and not over applying nutrients. All of these then have implications throughout all of these regulations of these various activities, including even getting down into the social and cultural heritage. And in Europe, you know, this is quite a big area of which there is strong urban support from consumers to seeing some of this cultural heritage and agriculture being part of the tourism and recreational value. I was in regions of Norway where basically they pay the producers to move their cattle up into the higher country in the summertime so that the tourists can come out to from the city and see sheep or dairy cows grazing out in those highlands because they find aesthetic value in that, even though, you know, from an economic perspective, it was just based on a productivity system, cost per unit of milk or meat produced. The producer themselves would have a greater incentive to leave them down in the intensive places rather than having them out in those highlands. But because of the cultural heritage, aesthetic value, the consumers within the urban areas are willing to pay for that value, and as a result, it happens. The other thing to keep in mind is that, as I mentioned, a lot of the efficiencies that we have are associated with the technologies that we have available. And part of the pressure that we're getting from the consumer side of things is to remove some of those technologies from our production system. So, as I said earlier, the consumer is entitled to their choice, and really I think the industry as a whole doesn't have much of a alternative but to meet the demands of what the consumer puts forward. But the consumer has to realize that if we're going to lose some of those technologies, there's going to be a consequence of that in terms of the efficiency, and that has implications throughout all of the footprint parameters that I've just discussed. So this is actually a study that was done by Judith Capper, who's done quite a bit of modeling in the United States, where she was looking at if they removed things like implants and the use of antimicrobials, some of those additives that we're using now for improved efficiency, what would be the consequence of that? Well, the consequence would be they would see a 11.8% increase in the beef population in order to produce the same amount of meat. The amount of feedstuffs consumed would go up about 10%. The amount of land required would go up 10%. Water uses would go up about 4.2%. Carbon emissions would go up about 9%. And the reduction in efficiency and the cost to the producer itself would represent about an 8.2% tax on beef cattle production. So I don't know whether there's anything, you know, that the industry can do if the consumer demands that they want hormone-free beef, but produce hormone-free beef, but they need to be aware that there's going to be other negative consequences as a result of that decision. And that's why, you know, as a scientist, we very much obviously advocate for science-based decisions. And when you look at the use of those hormonal implants, the residues that end up are none make it through to the animal and in the meat itself. And so there is no scientific evidence to say that the use of implants in cattle production systems has a negative effect on the safety or the health of the meat that's produced. And as a result, you know, I would say that it would be kind of a shame to lose that technology and then in turn have these increased impacts that we really don't want from a production perspective. And I think part of my job is to try to also make the consumer aware that if they select that direction, there is going to be consequences associated with that. So Fawn talked about the Canadian Roundtable for Sustainable Beef Production. This is really a global phenomenon. It's going on all over the world. Some countries are more advanced than others. I'd say Canada is one of the most advanced in terms of us, Canada having its act together in this area. It's very much going to be used from a marketing perspective as we move forward. So if a particular country doesn't get on board for this and doesn't recognize the significance of it, I'm sure that countries that do get on board will be using that as a reason to say why their product has better qualities than the competitors. And I think we see that already, even in the retail sector, in that they see that the consumers are demanding this kind of accountability, and so they're coming back to the producers, to the livestock production sector, saying, okay, we need assurances that these things are being done because our consumers are demanding it, and ultimately the consumer is the boss, and so we need to meet the requests. And so I think it is interesting, though, that other organizations that we typically wouldn't think would be getting involved in this as directly are on side, like the World Wildlife Fund, like the Rainforest Alliance, National Wildlife Federation, organizations that we typically did not see or really equate to being associated with livestock production in the past. And I really think that that's arising because they also see the writing is on the wall from the perspective where I described about the increase in the wealth of people across the globe, generally speaking, that greater wealth leads to an increase in meat consumption. There are some people who are going to select not to eat meat, but that's still not going to result in a reduction in meat consumption globally overall. In fact, meat consumption is going to go up. And so I think these organizations have seen that that's going to be the future. And so they've got on side. They want to work with the organizations, with the producers, with the livestock production associations to try to make sure that those organizations are aware of their concerns, but also to try to achieve those efficiencies. If those kinds of selections are going to be made, if that's the direction we're going, how do we do that with the least amount of impact or undesirable impact as we can possibly achieve? And this is just another group of, it's known as LEAP, the Livestock Environmental Assessment and Performance Partnership. This was the group that I was just working with in Africa on the water footprint related studies. Basically, this group is trying to establish some international standards for how we estimate these footprint parameters. And I think we have to be cognizant of that, because you do have groups that that can even get involved in these activities that have interests in showing that their particular footprint is lower than their competitors' footprint. And we need to establish standard protocols, standard practices, so that people really can adjust the numbers to get the kind of results that they want. They have to follow standard accepted protocols to get the end result, to avoid people from making those kinds of adjustments to try to make their footprints basically lower than they actually are by changing the numbers up or changing the relative weightings and parameters that go into the models, etc. So the take-home points, I think we have to drive, like even when we're talking about carbon or we're talking about water or even nitrogen, we're talking about cycles. So matter is not created or destroyed. We're always talking about cycles. So the water is not used. Even the water that's in urine has value. That water is evaporated, goes up into the atmosphere, comes back down as rain. So I know a lot would say that, I think a lot of people out there in the general community that would think, well, water is useless if it comes out as urine. But that's not the case. There's still water there. Newton's third law, for every action there's an equal and opposite reaction. We need to be aware of our actions. So I think that no industry is infallible in terms of its practices. We have practices in the beef industry that we definitely need to improve. And I think that that's part of the benchmarking exercise that Fawn described as well, is to know where we're at so that we can make improvements from that point going forward. Every producer needs to be aware of that, and every producer needs to be engaged, and that's challenging when you have 65,000 producers, and some of them have a couple of other jobs besides looking after the cows as well. Time can be a factor. But the groups out there that have those special interests that I described are really looking for mistakes that occur, and every industry makes mistakes. And those groups, because now everybody has a camera with them in the form of their cell phone or a video that they can take, they're looking for those kinds of incidents to take place, and then they're trying to blow those incidences up into as big a deal as they possibly can, get as much press coverage, get as much international coverage as they can achieve by doing that. And the consequence of that is they're trying to really brand the industry that that's the normal practice, not the exception. And so that's something I think we need to be aware of, and we need to try to minimize those mistakes as much as we possibly can. And when they occur, we need to demonstrate that we deal with them rapidly, and we put steps and processes in place to try to ensure that they don't happen again in the future. The attitude, and I think from the voting, I'm not sure we need to be as concerned about this as much as we did maybe 10 or 15 years ago. Based on the vote we had there, it looks like people are very aware in the industry with regard to the social license to operate. This statement is, the way we've always done it. It's a way of life. We're going to just keep doing this in the future, and we don't care what anybody else thinks. That kind of thought, I think, has already largely left the industry, and it's recognized that we have to be aware of the factors that give us a social license to operate, and that we just can't do it the way we always did it in the past if those practices don't meet some of the requirements we need to ensure our sustainability into the future. I mentioned a little bit about how consumers are continuously evolving. We've seen how quickly information can move across the community. People are much more aware of their food. There's probably nothing they're more sensitive about in terms of their food, in terms of the consumption and the food safety and the quality, and knowing where their food comes from and how it's produced is very important to the consumers, along with the price in terms of how much it costs to produce that as well. I really think that understanding the footprint for not only scientists but the entire industry to understand the footprint and some of the dynamics that I've described here in my presentation will help you explain to your neighbors, to the people that ask about how beef is produced, what are the various upsides and downsides of beef production, what are the advantages of beef production over other livestock and how it's produced, and what are some of the challenges that we're facing with it as well. All of those things we have to have an understanding of, so that when those criticisms that we come up, especially the ones that are often exaggerated and only present one side of the story, we'll have the knowledge and the ability to come back and really present a more rounded picture of what the industry really is, rather than the one that's from the perspective of people out of a vested interest in showing that the industry is bad. So I just want to thank the environmental footprint, the carbon footprint project that I mentioned that are already published, all the authors. It was a joint effort between the University of Manitoba, who was directly involved in the project, as well as Canada, and Environment Canada was involved as well in that study. We're now going on to Getahan, who's a lead scientist on the project in Manitoba, is going on now. We're defining the water footprint of beef production in Canada, and we have plans to also move on to some work in carbon sequestration as well. And ecosystems and services, we have another team working on that as well. Sarah Pogue is a visiting scientist here at the center that's also working in that area in conjunction with Jim Byrne and ourselves at the University of Lethbridge. And I just want to thank the research team that works within my lab group. This is back in 2013. We just had the Christmas party on Friday, so we haven't got the picture into my PowerPoint yet, but I'll have a new one in shortly. So with that, thanks very much, and I'd be happy to try to address any questions that come through the system.
All right, thank you very much, Tim. So we'll open it up to questions now from everybody. So if Fawn, if you want to share your camera and unmute yourself as well. Please type your questions once again into the chat box on the side of your screen. If your control panel has closed, you should see a little orange arrow near the top of your screen, and you will just be able to click on that, and that'll open your chat or your control panel again, and you can type in your questions. So we already have a few coming in already, so make sure you get them in early. The first question we have is, do you think, this is for Tim, do you think that soil research will try to look at understanding humic material under the lens of carbon sequestration?
Yeah, that's part of the picture. So humates are part of the less mobile carbon that I described, because chemically they're quite complex and they take a very long time to degrade within the soil. So some of that material that could accumulate in those deeper depths and that over time could be related to the humates as well. So that's definitely part of the overall carbon picture within soils for sure.
The next question is for Fawn. So what is the process, or who would they talk to become a verified cow-calf operation?
Yeah, so over the next year, we are going to be verifying a number of producers sort of in a continued trialing as we get our verification system up and running. And so people can sign up for that on the CRSB website.
All right, and oh, go ahead.
Yeah, and another thing, so of course we're not going to be able to verify over the next year all producers, and so I encourage people to get involved in existing programs. So whether that's in ProAction on the dairy side, or whether that's the verified beef production, or a multitude of other programs out there, such as environmental farm plans, the feedlot animal care assessment tool, all of those will prepare you very well, if not establish full equivalency between those programs.
Great, thanks. And I will be sending out a link or some supplemental information as well after the webinar, along with the recording of it. So I will provide the links for the CRSB website as well. So our next question is for Tim. So when calculating the feed conversion for beef cattle, what type of forage was considered for the grazing portion?
Well, it depends, a lot of that depends on the maturity of the forage at the time that it's consumed by the animal itself. So a high level of feed efficiency would be 5.5, 6 to 1 for a forage-based diet. It'd be very difficult to get the levels down to 5 to 1 with typical forages that would be available. As you go to greater maturity, so later in the fall when the material is in full flower, then that level of efficiency may go from 7 to 8 to 1. It depends again on the forage type and the level of lignification that takes place in the plant that the animal is consuming. And if you get into straw, like barley straw, which is obviously a very low quality forage, then you'd be getting into those really high levels, 10, 12 to 1. But typically, we don't produce a lot of cattle for production purposes, whether it be meat or milk, using that low quality of forages in this country. They do in other countries like Africa, but that's why they have also a very high footprint associated with their production, because it takes so long for an animal to reach market weight in those production systems.
All right, thanks. So I have a couple more questions coming in, so just a reminder to type your questions into the chat panel or on the side of your screen, and then we will get to those. So the next question here is there agreement in calculating carbon footprint?
That's for me too?
I would assume so.
Okay. The answer to that is, like the IPCC approach that's used is pretty standard. It's pretty much the standard that's used internationally. But there are a number of assumptions in terms of production systems and that go into developing the overall footprint estimate. So there are procedures that go in that are fairly standardized, but part of the footprinting process is to where there is limited data available or assumptions have to be made to derive that data, that those assumptions and calculations as to how that data was derived are very clearly stated. And that's what leads to variation in the footprints as well, is the nature of those assumptions that are made. There is no standard for the assumptions. Those differ depending upon the production system you're talking about.
Right. So my next question here is for Fawn, on your presentation, you talked about the different priorities for the CRSB. How were those developed?
Yeah, so they were developed using the results of the sustainability assessment. And then at our semi-annual meeting, we took those results to CRSB membership, where we attained feedback from them on what are the areas that they would like to work on. That then went to the advisory committee for the sustainability report, the whole sustainability report. The consultants helped myself and our other staff member, Monica, put it all into a document. So it was really from CRSB membership at our semi-annual meeting, and then the continued feedback from the steering committee.
Great, thanks. So the next question for Tim, you stated that globalization will play an important role guiding the beef industry in Canada. How can our producers gain a competitive advantage producing sustainable beef? And does sustainable beef involve minimizing conventional feed production and moving into a grazing system?
Well, I think a lot of that becomes, there's a number of factors that go into answering that question. A lot of it depends if you look at us competing globally. In a grass-based system, it's very difficult for us to compete globally with countries that can grow grass all year round. And that's one of the realities of our production system. Where we do, I already think we compete quite well in very high quality beef, and that's part of our integrated system, which involves the cow-calf sector and the feedlot sector working hand in hand towards producing that high quality beef. And that also is related to the genetics that we have in our herds as well. So I think that really gives us a competitive advantage. I would go to say that we probably produce the highest quality beef of any country in the world because of the consistency of our genetics and our production systems that we have. So I think to go to a straight forage-based system would make it very difficult for us to compete with countries like Brazil, New Zealand, Australia in their grass-based systems because of winter.
Okay, one more, or I got two more questions here, I guess. So the first one for Tim, I'm assuming. So the question is talking about how modern agriculture relies on the use of non-renewable resources, and they're just questioning, is this really sustainable, or an appropriate word to describe as sustainable production? Would something like degree of carbon neutral production seem more defensible?
Well, I think, just recognizing the role of carbon and carbon emissions in production systems is part of moving towards being more carbon neutral. I think our production systems that we have, our society as a whole as it stands today, if we're going to, I find it very difficult to see that if we just gave up with fossil fuels tomorrow, that we'd maintain the same standard of living that we have today. And it's true that our production systems, a lot of our agricultural production systems, our ability to produce so much food by so few people like we do in North America today is, again, due to the mechanization and a lot to do to the fossil fuels that we use in our agricultural production systems. And that doesn't matter whether we're producing those crops for feeding livestock or for feeding humans. It's the same sort of thing. If we wanted to go back to subsistence type farming, it really involves changing the direction that urbanization has been going on a global basis, and that everybody goes back to growing their own food in their own garden, which I don't think is very realistic either because of where we've seen people move in terms of their professional expertise. I think there's a lot of people out there that would require, because they've been away from crop production, food production, etc., would we need a lot of coaching, etc., to go back to producing their own food. So it's just, if you look at globally, and it doesn't matter where you look in the world, that's not the direction mankind is moving. Mankind is moving towards urbanizations. They're building cities like crazy in China. They're urbanizing even in Africa. And so everywhere in the world, the size of the population that's responsible for producing our food is getting less, and the amount of food that each individual is producing is getting greater. and a lot of that is due to the technology and our reliance and our use of that technology, which is largely also related to using fossil fuels in food production. So I don't see that changing direction anytime soon.
All right, thanks, Tim. So our last question here is for Fawn. So they're asking if there's any projects in northeastern Ontario and where could they find information on that?
Regarding sustainability, I guess. So I suppose there's more national or provincial programs that you could get involved in. So certainly the CRSB sustainability program is going to be national. So you can sign up on our website if you'd like to be part of the trials. But of course, there's environmental farm plans. There's beef code of practice, and making sure that you know that inside and out, that you could be a part of. Yeah, I suppose getting in contact with your local beef producer associations or local agriculture reps would help you connect with those resources as well.
Great. So there's just a couple more things to let you know about before we go. One is how to get science-based production advice through the BCRC. So you can go to our website, beefresearch.ca, and click the subscribe button to sign up for our free email list. If you have a Twitter, Facebook, or YouTube account, you can connect with us there as well. And I would also encourage you to sign up for the Canadian Cattlemen's Association email as well, called Action News, and you can sign up for that on the cattle.ca. I wanted to let you know about our next webinar, which will be taking place Thursday, December 8th, and we'll be talking about managing young calves to present disease, so make sure you join us for that one. So very shortly, as soon as the webinar ends, you're going to be asked to complete a short survey that asks about tonight's session and what you're most interested in for future webinar topics. We do need your feedback to do the best we can to deliver information that's both useful and meaningful for you to use on your operation. So please complete that survey and don't hesitate to contact me with any questions, comments, or feedback you might have. You'll also receive an email from me within the next couple of days with a link to watch the recording, as well as a link to some additional information on sustainability and the environmental footprint of beef production. So that's it. Thank you everybody for joining us tonight, and on behalf of everyone, thank you Tim and Fawn for volunteering your time and expertise.
Thanks a lot, Stacey.